You know how it is when the wedding season starts. Every second day one has to attend a wedding or the other. In fact, that is one of the reasons why I am here. I need to buy a few clothes for a wedding which I have to attend a couple of days from now. The salesman here has offered me a deal. He says he will give me 2 shirts and 1 pair of trousers for 2,000 rupees. And when I bargained further with him, he said he would give me 4 shirts and 2 pairs of trousers for 4,000 rupees. Now which deal should I take? Thankfully, I know linear equations. And you've guessed it right. That is the topic of the day. It's time for Math 10 with me, Pawan. I'm here to take the theory out of the theorem and the fever out of the exams, and also to make sure that you max those marks. So we are all set to make math work for us. So after today's episode, you will be able to understand the concept of linear equation in 2 variables, solve linear equations of 2 variables graphically, and decoding all exam tricks and traps. Now suppose you were to buy this coffee mug and let's say this coffee sachet, and let's assume the price of a mug to be X and that of a sachet to be Y. I would always want you to appreciate the transition from real world to X's and Y's. Now let's say there is a seller who offers 2 mugs and 4 sachets for rupees 60. And let's say he also offers 1 mug and 2 sachets for rupees 30. Now, let's look at the first equation that we can form. The first equation can be 2x plus 4y equals 60. Why 2x? Because there are 2 mugs. And why 4y? Because there are 4 sachets. So 2x plus 4y equals 60 is our first equation. Now, any equation which can be put in the form ax plus by plus c equals 0, where, very importantly, a, b and c are real numbers, and also a and b are both non-zero, then it's called a linear equation in 2 variables. And what are those 2 variables? X and y. For example, I think it's important that I take an example here. Let's say if x equals 0, then what happens? Y will come out to be 15. And if x equals 2, y will come out to be 14. So you can go on and on and on and put n number of values and get different values for y. Now, what happens if x is 1 and y is 1? Do you notice something different? Let's have a look at the left-hand side of the equation. What do we get? 2 into 1 plus 4 into 1. And what does that equal? 2 plus 4, which is 6. Which is of course not equal to 60. So if we have x equal to 1 and y equal to 1, that does not satisfy this equation. But otherwise, the equation, as I've already told you, will have infinite number of solutions. But if we also have, let's say, another equation like x plus 4y equals 30, now these 2 equations together will form a pair of linear equations in 2 variables. Similarly, if we consider 2 equations in 2 variables simultaneously, as I've already told you, these are called a pair of linear equations in 2 variables. So the general form of a pair of linear equations is a1x plus b1y plus c1 equals 0 and a2x plus b2y plus c2 equals 0. Where, remember the condition, it's very important. a1, a2, b1, b2 and c1, c2 are all real numbers, and a1 squared plus b1 squared is not equal to 0. And a2 squared plus b2 squared is also not equal to 0. You need to remember these conditions very clearly. We know that a linear equation in two variables geometrically represents a straight line on the graph. Now, let's take one line which represents an equation on the graph. If we take another line on the same graph, there might be a few conditions, very interesting conditions. Let's look at them. The first condition would be they might intersect in one point, or they might not intersect at all. They might be parallel lines, in which case they will never ever intersect. Or the third possible condition is they are overlapping or coincidental lines. That is, they combine together into a single straight line. Today we will deal with all these lines and pairs. I have this painting here. I'll give you a couple of conditions. Now the sum of length and breadth of this painting is say 3 meters. Let me give you one more condition. If 2 times length is added to 3 times breadth of the painting, let's say we get 7 meters. And now I will throw a question at you. How do we calculate the length and breadth of this painting? We immediately need to move from real life to x and y. So let's say the length of the painting is x and the breadth is y. So what do we get? We get x plus y minus 3 equals 0. Listen to me very carefully. It's very important that you form your equations correctly. Now, shall we form the next equation? 2x plus 3y minus 7 equals 0. Now let's concentrate on the first equation. If we rearrange the first equation a bit, we get y equals 3 minus x. Now, do you remember what I told you in the beginning? For a number of values of x, we can get a number of corresponding values for y. So what will I do now? I will take the equation, take some value of x, and find the corresponding value of y. Similarly, I look at the second equation. The second equation is y equals 7 minus 2x over 3. So, again I'll do the same thing. I'll take a number of values of x and find the corresponding values of y. Now all these values that we've got, let's put all these values in the table form. So when x is 0, y is 3, when x is 1, y is 2, when x is 2, y is 1. Similarly, for the second equation, when x is 2, y is 1. X is 5, y is minus 1. X is minus 4, y is 5. Now, if we actually draw a graph for the equations of these two straight lines, what do we get? These two lines will actually intersect on the graph and intersect on exactly one point. Now what happens? What it actually means is that the point at which they intersect, that is the solution of the equation. What is that point? That point is, let's say A, and the coordinates of that point is 2, 1. So this pair of lines is called consistent. Why consistent? Because they intersect at exactly one point. Now, there's something very interesting if you look at the equations. Why not compare the coefficients of the two equations? So if we compare the coefficient of equation 1 and equation 2 with the corresponding coefficients of the general form of linear equations, which you are already aware of. I've already discussed that initially. So what is that general form? a1x plus b1y plus c1 equals 0 and a2x plus b2y plus c2 equals 0. So now if we are ready to compare, we get a1 is 1, b1 is also 1, and c1 is minus 3. Now let's look at a2, b2 and c2. a2 is 2, b2 is 3, and c2 is minus 7. You know what we are going to do now? we will find the ratios. Which ratios? We'll find first the ratio between A1 and A2. And what is that ratio? Simple, 1 over 2. And what about B1 over B2? That is 1 over 3. So what can you say about these two ratios? Something that you can directly say is that the two ratios are not equal. Of course, 1 by 2 is not equal to 1 by 3. Now notice that straight lines as graphs of linear equations a1x plus b1y plus c1 equals 0 and a2x plus b2y plus c2 equals 0 intersect each other at a point only if a1 by a2 is not equal to b1 by b2. And I'm repeating this, they are called consistent equations. So, if we don't want to draw the graph of the linear equations and still want to know whether they are consistent or not, you know what we have to do. Just find the two ratios. Find A1 by A2 and find B1 by B2. They should not be equal. Now that was a lot. So let's ease up a little and try to figure out what our caller has to say.
Hi sir, I'm Radhika. I'm in 10th standard. The show has made problem solving a real breeze. But I do have a doubt. If there are two parallel lines for a pair of linear equation, how do I solve it?
Well, Radhika, I'm sure you want to know the answer right away. But let's take a little time off and go on a break. Please don't be disappointed, because when I come back, the first thing I'll do would be to answer your questions. But right now, take a break and come back soon.